Okay, so we have a 1 hour time limit here. So we need to complete within it. Okay, so this one we haven't discussed in class. It's an, what do you say, extended thing. So which of the following ICH harmonized tripartite guidelines, means ICH guidelines related to stability, provide approaches that allows for bracketing and matrixing design for stability testing? This is especially important when a new drug product is to be commercialized with multiple strengths in multiple packaging configurations. So first thing you need to know, all the guidelines are given by ICH as QSEM. Q is for quality, S is for safety, E is for effectiveness, and M is for miscellaneous. So जो भी Q1 guidelines है, Q1 guidelines, I hope you all are making notes, okay, as in when I'm speaking. Q1 guidelines hai, all of them are related to stability of a drug substance or a drug product. Okay. It is related to stability of a drug substance or a drug product. So उसमें से Q1A, Q1B, C, D, E, F तक जाता है ये. So in that you have one guideline which is going to help you for the bracketing and matrixing design. Okay, now it is one design वो तुम लोग masters में पढ़ोगे. Bracketing and matrixing design is used for stability studies. Okay, so which of these guidelines is going to help you? And the answer here is Q1D. Okay, Q1D is going to help you for bracketing and matrixing design. Q1A is for the stability. Okay, Q1A R2 is for the stability of a drug substance and a drug product. Q1B is for photostability. Q1F is for climatic zone 3 and 4. All right. So go to the ICH का website और एक बार बस ऊपर से देख लो Q1A क्या है, Q1B क्या है, S1 क्या है, and all of that. Okay. I think if you all have any doubts, that can be done at the end. All right. So now this is what we've discussed in class. Movement of a charged particle through a liquid under the influence of an applied potential difference is known as what? Anuja.
Electrophoresis.
Good. The answer is electrophoresis. Streaming potential and sedimentation potential में क्या होता है? When the particles are moving, okay, streaming potential में when they are moving in a planar thing, and sedimentation potential में when they are settling down, तभी movement of the particles are causing generation of a potential, okay, and electrophoresis, electroosmosis में potential के वजह से movement हो रहा है. There's nothing osmotic about this statement, right? There's nothing membrane से जा रहा है and all of that. So this is ruled off anyways. बचता है electrophoresis. So the right answer is electrophoresis. In pre-formulation study, polymorphs can be detected by Salone.
Yes, ma'am.
What do you think the answer is?
Ma'am, it's option A.
DSC. Very good. So polymorphs में DSC कैसे retractometry, then countercurrent chromatography and HPLC, they are used for separation and identification of a compound. Okay, separation and identification. But when you have two polymorphs जो structurally same है, okay, I mean molecular formula उनका same है, but then there is arrangement का difference उनमें. So that will be detected by DSC. Why? Because DSC is going to tell you the melting point of the substance, and polymorphs will have difference in their melting point. Make a note, techniques like DSC, techniques like X-ray, diffraction, okay, infrared spectroscopy, IR, okay, all of these are used to detect the difference in the difference amongst the polymorphs. Okay, so ये सब techniques से तुम polymorphs के बीच का difference देख सकते हो. Next, pyrogens present in containers can be destroyed by heating the containers at Shmita.
Ma'am, option C.
121 degree, no. It's option D. 121 degrees, 30 to 60 minutes hota hai time. All right. So the
Okay,
option
ma'am.
is D. 210 का नहीं होता है कभी. Autoclaving is what is being discussed here. Moist heat sterilization, right? So it is option D, 121 degrees, 30 minutes. 30 to 60 minutes hota hai. Next. Okay, so now you have to match the ingredients found in a, like the content of the rubber closure with the ingredient, activator, curing agent, accelerator and all. Samir. Samir?
Yes, ma'am.
What's the answer?
The options are below. So can you do that?
Oh yeah. But you can see, right? Activator kaun sa hai, curing agent kaun sa hai. Anybody else wants to voluntarily answer this?
Option A.
Who's this?
Sonika, ma'am.
Huh? Zoya.
Ma'am, I think it's D.
कौन बोला पहले? So option A is the right answer. Samir, you need to study. Activator. Activator में तुम्हारा stearic acid, zinc oxide आता है. Curing agent को दूसरा नाम क्या है? Vulcanizing agent, जिसमें sulfur आता है. Then you have your peroxide. Sulfur is more widely used. Okay. So first you see A का answer is 2 and it's just in option 1, right? So वैसे करके तुम match कर सकते हो. या फिर even if you know curing agent का peroxide है, तो B5 भी सब सिर्फ एक में ही है. Okay, so अगर ऐसे भी करके if you are very sure that curing agent में peroxide आता ही आता है and B5 एक ही option है, so you straight away you can mark this, right? Fillers में you have carbon black and all, right? Elastomers में तुम्हारा regular rubber and सब आता है. Accelerator में you have this, it is zinc actually. Okay, so in match the following, this should be your approach. कोई भी एक लो, match it if you're 100% confident. Okay, match it, check it कि is it exclusive. Suppose अगर B5 यहाँ भी है, B5 यहाँ भी है, then you pick up something else and see कि वो अलग है कि नहीं. और जो option में तुम्हारे हिसाब से जो correct वाले हैं वो आते हैं, you can straight away mark that. Okay?
Yes, ma'am.
Okay.
Yes.
So an excipient Ludi press used for liquid dosage form is a co-process excipient of. So I don't think this is there in your book. While teaching you all monophasic also, I've not come across this or any other thing, right? So Ludi press दो forms में available होता है, Ludi press as such and Ludi press LCE. So here it is asked Ludi press में क्या होता है? So Ludi press में you have lactose monohydrate and you have Colidon 30. Okay, you have lactose monohydrate and you have Colidon 30 in Ludi press. If it is Ludi press LCE, मतलब LCE 3 components है, वैसे याद रखो 3 components है तो 3 चीजें है. कौन सी? लैक्टोज मोनोहाइड्रेट, कोलिडॉन 30 एंड कोलिडॉन CL भी आता है उसमें. ओके, यू ऑल नो राइट, कोलिडॉन इज नथिंग बट पोविडॉन K30. ओके, एंड कोलिडॉन CL इज क्रॉस पोविडॉन. Are you all making note of this?
Yes, ma'am.
Yes, ma'am.
Yeah. So here we just have Ludi press. So Ludi press में there's just lactose monohydrate and colidon. और इसका percentage क्या है? This is 96.35 lactose monohydrate and colidon 30 is 3.5. And Ludi press LCE अगर है, then lactose monohydrate is 93%, colidon 30 and colidon CL is 3.5% each. Okay, that's the thing. Dextrose monohydrate should go off in your first thing only. For that you should know कि इसमें क्या आता है. How are you going to remember? L for Ludi press, L for lactose monohydrate. LCE नहीं है तो 2 items, LCE है तो 3 items. So these two can be eliminated, and because no LCE, even this can be eliminated. All right.
Yes, ma'am.
If you all have doubts, please make a note of it then and there. We shall come back and discuss. Okay. Which of the following is not a mechanism for achieving gastro-retention? Have you all learned this? Yes or no?
Yes, ma'am.
And I'm also making a note who is answering and who is not.
Ma'am, B, osmosis.
Yes, ma'am. Osmosis.
Who's this? पहले किसने बोला?
Ma'am, Yashvi.
Very good, Yashvi. I'll appreciate if you all raise hands, okay? Correct. Osmosis is not a mechanism for gastro-retention. Floating will be gastro-retention. तुम्हारा जो भी dosage form है, that will float in the gastric fluid. Swelling is one. Okay, swell होके वो retain हो जाएगा. It won't go down through the duodenum and all, and it will retain. Peristalsis movement से वो next small intestine तक नहीं जाएगा because it has swelled up. And mucoadhesiveness, it will adhere to the mucous lining of the stomach. So these are the 3 main approaches. Osmosis doesn't work for gastro-retention. Preservatives are generally not added to.
Large volume parental.
Who's answering? Trupti. Who was this?
Ma'am, I raised the hand, but somebody else answer. LVP.
Okay. Trupti, what is the answer then?
Ma'am, even I think the same, large volume parenterals.
The large volume parenterals में नहीं आता.
Small volume, ma'am.
अभी ये कौन बोला? Who was this? Small volume wala?
No, man.
No, man. Small volume is the correct answer. Large volume mein you will require. Small volume, single dose mein you don't require. Multi-dose mein you require. Large volume mein you will need some amount of preservative. Okay, but उसका percentage low होना चाहिए. Small volume parenterals में नहीं required होता है. All parenterals is also not an option. And bacteriostatic water for injection में भी नहीं लगता है. All right. So these three things are not right. The most correct answer here, I would say, is small volume parenterals.
मैम,
Oh.
टू बी ऑनेस्ट जितना मुझे याद है आपने ही बताया था कि एलवीपी में नहीं करते हैं ऐड, एंड इवन सेम थिंग हैज बीन टॉट इन कॉलेज आल्सो.
यस मैम.
LVPs में नहीं ऐड करते हैं.
यस मैम. प्रिजर्वेटिव्स.
Yes, ma'am.
And
We'll come back to it. We'll come back to it at the end. Okay. For now, I'm marking SVP. We'll come back to this. Okay.
Okay, ma'am.
But remember one thing, small single dose में you will never add, multi dose में you have to add. Okay. ये point note कर दो. Hello.
Yes, ma'am.
Yes. Next. I think this is quite easy.
B.
F.
Co-solvency.
Why are you all answering out of turn? Anyways. So increasing solubility of weak electrolytes and non-polar molecules by addition of a water-miscible solvent in which the drug has good solubility will be co-solvency, definitely. Complexation में क्या आएगा? Complexation में cyclodextrins and all आएंगे. Correct?
Yes, ma'am.
Complexation में cyclodextrin बना, there'll be moiety जिसके साथ तुम अपना drug complex करोगे, and then you will dissolve it in the dissolve or solubilize it in the solvent. Solubilization is the regular technique. Hydrotrophy भी इसमें नहीं आएगा, उसमें you are going to make changes to the chemical moiety. So when you use a third agent, okay, here a water miscible solvent, when you use a third agent to increase the solvency, that becomes the co-solvency method. All right.
Yes, ma'am.
Please don't answer out of turn, huh? Hepa filters are defined as dash, matlab as A or more efficient removing from the air B particles generated by vaporization of hydrocarbon MORE 3004. Okay, so matlab here it's asking ki Hepa filters ko kitna percentage effective hona chahiye, efficient hona chahiye, and what size of particles can be removed by them. So Swapnil or Trupti, you haven't answered, right? Trupti.
Yes, ma'am. Ma'am, I think the answer is A. Maybe option B. A 99.9%, B 0.3 micrometer.
You sure?
Actually, I'm confused between 0.1 and 0.3.
Option B, ma'am.
Ma'am, it's B.
Who's this?
0.3.
It's B,
Ma'am,
correct.
Noman.
ये भी parenterals में ही सिखाया है. Production में सिखाया, parenterals के production section में. And तभी भी मैंने बोला था, remember this. ये तो easily याद रह जाएगा, 99.99%, just like Dettol. Okay? But ये याद रखना है, 0.3 micrometer का particles निकालेगा. 0.3 micrometer मतलब 300 nanometer. उतने बड़े particles वो निकाल सकता है. 0.1 is very small. ठीक है? So it is this. Understood?
Yes, ma'am. Yes, ma'am.
Good. Okay, now this is a little contradictory thing. Consider two of the answers as correct answer here. Okay, and raise your hand and answer, please. Sonali.
Yes, ma'am.
What's the answer? You've raised your hand, right? Which of the following statement is
Ma'am, it was for earlier.
Then put your hand down.
I'm not.
Nobody who's going to answer this? Which of the following statement is not true?
Option B.
I said more than one answer is क्या?
Option B.
B and C.
B and C is the answer.
Yes.
C and D, ma'am.
Hello, ma'am.
Yes. Anna.
Ma'am, option A and D.
A and B are right. So maybe B and C is the answer.
B and C. Bulkiness increases with decrease in particle size.
Ma'am, it's true.
Bulkiness will increase with decrease in particle size. As your particle size decreases, the bulkiness will increase. Tell me.
Yes.
Assuming your material is not fluffy in nature. Okay. If your bulkiness, if your particle size is going to decrease, छोटे particles hai, so will the bulkiness increase or decrease? Bulkiness क्या है? The bulk, right? 5 ग्राम का मैं A substance लेती हूँ और 5 ग्राम का मैं दूसरा substance लेती हूँ. If the second substance is occupying more volume, that means it is bulky. Correct?
Yes, ma'am.
So how you are saying that this is correct? And second option, smaller particles shift between the larger ones and increase the bulkiness. This is the wrong, right?
Yes, ma'am. It decreases the bulkiness.
Yeah. Smaller particles will shift, वो voids भर जाएंगे, correct? Voids भर जाएंगे मतलब less volume occupy होगा. Don't you think the same is applicable here also? Bulkiness will decrease with decrease in particle size. Next option, let us come to bulkiest substance will require larger container than that for less bulky substance.
It's true.
It's true, ma'am.
Right? So C is, मतलब मैंने अभी example दिया. So C is ruled out anyways. Reciprocal of bulk density is bulkiness.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
True, correct? So C or D, that is ruled off, correct? बचता क्या है? ये दो. So here the answer is both of these. Do you all agree?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah, so this is the thing. यहाँ पे there's an error, but I asked for this question to be kept for this discussion. All right? Always understand. And suppose fluffy material होता है ना, fluffy material तो वैसे ही fluffy ही रहने वाला है वो. वैसा कुछ होगा तो maybe question में specify होगा. Whenever there is such generalized questions asked, even you need to think in a generalized perspective. Do you all agree to this कि particle size हम कम करेंगे तो void space भी कम हो जाएगा, right?
Yes, ma'am.
The bulkiness will decrease. So the answer is A and B here.
Hello, ma'am.
Yes.
I quite didn't understand the fourth option. The bulkiness.
Reciprocal of bulk density is bulkiness. We'll
Yes,
come back
ma'am.
to it at the end. Okay, I'm making a
Okay,
note.
ma'am.
मैम बी वाला जो स्टेटमेंट है मैम वो भी क्लियर नहीं है.
We'll come back to this question. Okay.
Okay.
And दूसरा वो parenteral का था, right?
Yes, ma'am.
Yes.
And ma'am, if like even in the exam, if both answers are correct, so which is the more correct one that we have to choose?
The more correct I feel is this, B. Because this is, I feel this is very much logical that smaller particles will definitely shift between the larger particles. Okay. And bulk density be, yeah, they will shift between the larger particles and it will decrease the bulkiness. Okay.
Okay, ma'am.
Okay, now this is easy. For bitter drugs in pediatric formulation, excellent flavoring agent will be Swapnil. Swapnil. I'm actually making a note of who is there, who is not. Okay, Swapnil is not there. Akshaya.
Yes, ma'am. Ma'am, orange syrup.
It is a bitter drug. Were it to be a sour thing, it's a bitter drug. Yes, Swapnil. Soni Chauhan.
राजगिरी.
Yeah. Yes. Did you answer earlier the question? One question.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. The answer is raspberry. See, bitter formulations के लिए अच्छा, अगर bitter formulation for geriatric patients होता ना तो वो blackcurrant होता. But because it is for pediatric formulation, उनके लिए you will always prefer sweet, which is raspberry. Okay. Now, if it is some elixir kind of a thing, some sour kind of a thing, or some effervescent kind of a thing, तभी lemon लेंगे. And if it is a sour, then you will go for orange. All right. But bitter drugs, pediatric patient always go for a sweeter one, which is raspberry. Okay. And the colors associated would be a yellow color, yellow or a bright lime color, would be a red or a pink color. Blackcurrant would again be a dark color. Orange would have a orange color. ठीक है? Colorings associated to the flavorings. Sorry?
मैम लेमन सिरप.
लेमन सिरप क्या?
मैम कौन से फॉर्मुलेशन में यूज करेंगे?
लेमन सिरप तुम something again sour, some effervescent kind of a thing के लिए तुम lemon prefer करो. Elixir kind of a thing and all. Okay?
Yes, ma'am.
Okay. I'm just making a haste here because the time, I don't want the time to lapse. We can again come back to that PDF. Okay? ठीक है. Type 2 glass containers are
Option A.
Who's this? Sony.
Yes, ma'am.
Out of the turn क्यों बोल रहे हो?
Sorry,
Ikra.
ma'am.
Ikra.
Yes, ma'am. Ma'am, I think option A.
First of all, please stop saying I think यार. ये बहुत direct type के questions हैं.
Yes, ma'am. Option A.
Oh shit. Oh God. I think I just 1 minute, let me get back. We'll have to go back again. Okay, this one's done, right? Okay, fine. We'll come back to that question later. What about this? Which one of the following viscometers can be used for characterizing non-Newtonian system? Kef.
And cup and bob, B.
Very good. Cup and bob. Falling sphere का दूसरा नाम क्या है? Anybody can answer this. Falling sphere का दूसरा नाम क्या है? Come on. Falling sphere viscometer का दूसरा नाम is Hoppler viscometer. Okay, which is this. And both of, and this falling sphere is used for your Newtonian systems, right? Capillary viscometer, Oswald, which is your Oswald viscometer, then the suspended viscometer or the Hubelord viscometer, all, and falling sphere. All of these are used for your Newtonian type of your system. Cup and bob, parallel plate, cone and plate, all of these are used for your non-Newtonian system. Okay? जहां से तुम्हें उसकी rheological properties पता चलेगी. ठीक है? Is this understood?
Yes, ma'am.
Yes, ma'am.
This was quite easy. Here you're expected to know wo Sierral type, then Ferranti type, Shirley type, जो सारे different types है ना, parallel plate में कि cup and bob में and all of that. Okay, so please remember those. All right.
Yes, ma'am.
Yes,
Yes, ma'am.
Okay. This is again 121 degree, 30 minutes. Moist heat sterilization. DSC. Okay. This is also actually easy only. In India, the patent office, the head office is at Kolkata, branch offices are at, anybody can raise hand and answer this one. Manshi.
Ma'am, it's B.
Yes, correct. Mumbai, Chennai, New Delhi. Remember all the metropolitan cities. One in west, which is Mumbai, one in north, New Delhi, south, Chennai, or east mein Kolkata hai. That is how you're going to remember these. Okay?
Yes, ma'am.
ठीक है, ये भी हो गया रास्पबेरी. Again, I'll ask this. Ludicrous में क्या है composition?
Lactose monohydrate and choledone.
What percentage?
96.96.
96.95.
96.5 and 3.5. Okay. Osmosis and Ludicrous LCE में कौन सा है?
Lactose monohydrate.
Colidon CL.
CL additional है. And what is the percentage?
3.5.
3.5.
3.5.
And lactose monohydrate is 93%.
Yes. Okay. Electrophoresis here. Okay. I'll go right now with LVP, but I'll come back. I might have said this, right? That LVP में अगर तुम 3.5, yeah, I'm sorry. The correct answer is SVP. Are not added to SVP. Okay. Sorry, the correct answer is LVP. Preservatives are generally not added to large volume parenterals. I remember. I'm sorry for this. 3.5% suppose या 2.5% अगर हम बोलते हैं preservative है 2.5 gram in 100 ml and तुम्हारा LVP is of 1000 ml suppose, तो कितना हो जाएगा 2.5 gram का? If you are using a preservative 2.5% weight by volume, मतलब 2.5 gram in 100 ml, but if your LVP is of 1000 ml, तो preservative कितना हो जाएगा 2.5 के हिसाब से?
25
gram, right? So this becomes excess. This becomes excess, and we know that most of the preservatives are harmful. So that is why your LVPs may either you will use a minimal quantity or you will avoid using it and you will go with some sterilization technique. Why? Because percentage में अगर तुम खेल रहे हो तो accordingly वो बढ़ जाएगा. Small volume में you will use a little amount. Okay? And we are not taking, it is because how much is it going to be tolerated by the human body. Okay? बैक्टीरिया को मारने के लिए उतना परसेंटेज तो काफी है, but because either 25 gram is going in your body or 250 gram is going, or 2.5 gram is going in your body, right? So that is going to make a difference. Hence LVP में you won't use preservatives, and दूसरा single dose use में you won't use. Okay, single dosage वाले में you won't use. Agree to this? Any doubts? I'm sorry for the confusion earlier.
Yes, ma'am. No problem.
Yes, ma'am.
All right.
Yes, ma'am.
Yes, ma'am.
Bacteriostatic water क्या होता है? See, all parenterals तो ये तो पहले ही rule out हो जाएगा question. Okay. Bacteriostatic water for injection is this water is used for irrigation purposes, cleansing purposes and all that. ये वो dilutions वगैरह करने के लिए use नहीं होता है. Okay. This is also a sterile water only, but it is used for cleansing purposes and all of that. Wounds वगैरह को clean करने. ठीक है, we'll move ahead with this.
मैम एक स्टेराइल वाटर फॉर इंजेक्शन आता है ना?
हाँ.
उसमें हम प्रिजर्वेटिव यूज करते हैं कि नहीं मैम? आई हैव अ कंफ्यूजन बिटवीन दीस टू बैक्टीरियोस्टैटिक.
नहीं, वाटर फॉर इंजेक्शंस एंड ऑल दैट में यू वोंट यूज प्रिजर्वेटिव, बिकॉज वो अगेन वो स्टेराइल वाटर फॉर इंजेक्शंस एंड ऑल होता है ना, वो भी एम्प्यूल्स वगैरह में मिलते हैं, मतलब सिंगल डोज होता है वो. ओके, एंड दे आर टू स्टेरिलाइज्ड ओनली बाय डिस्टिलेशन.
तो मैम ये बैक्टीरियोस्टैटिक वाटर फॉर इंजेक्शन में हम प्रिजर्वेटिव यूज करते हैं ना?
नहीं, इसमें भी नहीं करते एक्चुअली.
मैम फिर तो इसका ऑप्शन लाइक बोथ में आना चाहिए ना?
बोथ में आना चाहिए, बट दिस इज मोस्ट करेक्ट. इसमें कभी कभार यू यूज डिपेंडिंग, बट जनरली यू वाटर फॉर इंजेक्शंस में यू डोंट यूज ओनली, यू गो विद दैट डिस्टिलेशन, डबल डिस्टिलेशन प्रोसेस एंड दे आर स्टेरिलाइज्ड. बट इसमें कभी कभार डिपेंडिंग ऑन द यूज केस there might be some amount of your preservative added, but again in a very minuscule quantity. Okay. Moreover, this also becomes your SVP. तुम्हारा बैक्टीरियोस्टैटिक वाटर फॉर इंजेक्शन है ना, वो भी तुम्हारा स्मॉल वॉल्यूम जैसे ही अवेलेबल होता है. It's not as large volume. So you can apply both these things. So even this is not the answer. Okay. Hello.
Yes, ma'am. Yes.
Who was it? जिसने डाउट पूछा उसी ने यस बोला कि किसी और ने बोला?
यस मैम, इट्स क्लियर. बट मैम मुझे बैक्टीरियोस्टैटिक वाटर फॉर इंजेक्शन एंड स्टेराइल वाटर फॉर इंजेक्शन में ना थोड़ा कंफ्यूजन है कि लाइक which one is pyrogen free और ऐसा भी एक क्वेश्चन है.
Both are pyrogen free. Who is this?
Ma'am, it's Mansi.
Mansi. We'll get back to this later, Mansi. Okay, we'll move ahead right now. Maybe you can contact me after the class.
Okay.
Okay, yeah. Okay, one of the following apparatus used to determine particle size by gravity sedimentation method.
Option C.
अरे नाम लेके बोलो यार. Who is telling?
Yes, ma'am. Option C.
Anderson apparatus.
Yes, ma'am.
Correct. Correct. What is pycnometer used for, Manshi?
Density.
For density. Oswald viscometer for viscosity. Friabilator. Friabilator क्या होता है? It's for friability. Okay. So the answer here is Anderson apparatus. I think it is very much clear to eliminate options here. Correct?
Yes, ma'am.
Yes, ma'am.
So we were on this thing, right? Anam, would you like to answer this? Or Yashvi?
Ma'am, A. Option A.
Option A, correct. Type 2 glass containers are suitable for acidic and neutral aqueous preparations. Okay, not for alkaline, not for non-aqueous. Non-aqueous के लिए तुम 3 या 4 use करोगे. Okay, and I don't know why is this even in the option. ठीक है? Can we move ahead?
Yes, ma'am.
Yes, ma'am.
Okay, I think Rashmita was answering this one, right? When we were solving the PDF.
Yes, ma'am.
What
B
do you
option, fluid extract.
Correct. The answer here is fluid extract. Tinctures में क्या होता है? Your whatever the content is, that is actually soaked in your solvents. Fluid extracts में you will always use an alcoholic preparation. Infusion is when you mix two solutions or when you infuse one extract with the another extract. Okay. And in this case, extract, which is a generalized term, it can be an oil-based thing also, it can be alcohol-based thing also. So because here alcohol is mentioned, so it becomes your fluid extract. Got it?
Yes, ma'am.
Okay. Which of the following oxide is not used for achieving amber color to glass? Anuja? No, wait, Anuja is done. Kajal. Kajal.
Yes, ma'am.
एम्बर कलर के लिए कौन सा यूज नहीं होता? ओके
Ma'am, C.
यस काजल.
Ma'am, C.
यस करेक्ट. तो सी किसके लिए यूज होता है? कोबाल्ट ऑक्साइड इफ नॉट एम्बर कलर कौन से कलर के लिए यूज होता है?
Blue violet color.
Yes, correct. Cobalt is always used for blue to violet color. Carbon, iron, carbon is again used for brownish color. Iron be reddish to brownish color. All of these fall in amber color category. Magnesium is also more or less used for amber color, but it will produce a greenish tinge. Okay. But it again comes in the amber color category. Got it? So cobalt is exclusively different. It will produce blue to violet color of this thing, your glass. ठीक है? And all of these are oxides. Remember that. Can we move ahead?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, so this was co-solvency. Theories of emulsification are characterized by one of the following, except. Who's going to answer this? Jui, are you there?
Yes, ma'am.
Yeah, I think this is really easy and very direct question. Theories of emulsification are characterized by one of the following, except, मतलब किससे नहीं होगा characterize?
Ma'am, solid particle adsorption.
Are you sure? It's solid particle adsorption. Okay.
No, ma'am. 1 minute.
अभी notes refer करके मत जवाब दो.
नहीं notes नहीं refer.
हाँ, okay. I hope you're not seeing your notes.
No, ma'am, not seeing.
What is it then?
Phase inversion.
पूछ रहे हो कि बता रहे हो?
नहीं बता रही हूँ मैम. Phase inversion.
Correct. Phase inversion is not a theory of emulsification. It is a technique. It's one of the preparation techniques of emulsification. Film formation, monomolecular adsorption, and solid particle will be your this thing. That will be your theory of emulsification. Got it? Film monomolecular adsorption में क्या आएगा? What type of agents represent or characterize monomolecular adsorption? See, you have hydrocolloids, you have small fine particles like bentonite and all, and then you have surfactants.
Surfactants will show monomolecular.
Yes, ma'am. Surfactant.
Okay, surfactants. Monomolecular कौन दिखाएगा? Sorry, monomolecular surfactants. Film formation कौन सा दिखाएगा?
Hydrophilic colloid.
Correct. And solid particles, तुम्हारे finely divided solid particles दिखाएंगे. So based on this, you have three theories for emulsification. Understood? Phase inversion becomes a technique. All right. Any doubts here? Hello.
No doubts, ma'am.
No, ma'am.
Okay, even this is done, right? Okay, which one of the following is the property of microemulsion? Matlab, which is true for microemulsion? Raise your hand and answer. Yashvi, are you going to answer के पहले के लिए ही हाथ ऊपर किया था तुमने?
No, ma'am. For this one, ma'am, option C.
Okay. Anybody else? Anybody else?
Yes, ma'am. Option C.
Okay. They have particle size more than 1 micron. No, it's a microemulsion. It will be a उसका कम होगा, 1 micron से कम होगा. They have milky yellow color. नहीं, they are transparent in color. Poor stability. You might say they are thermodynamically unstable, but then that is taken care of by use of surfactants and other stabilizers. Okay. But the fact that, okay, so all of this is not true. Okay. They exhibit a viscoelastic gel phase when internal phase is added in excess. Matlab, when you add more, suppose if you're having oil and water kind of an emulsion, you are adding more of oil phase to it, उसका viscosity बढ़ने लगेगा, viscoelastic बनने जाएगा, and it will become more hard. Okay, ज़्यादा shear लगाना पड़ेगा for it to मतलब for any process तुम्हें ज्यादा shear लगाना पड़ेगा. So this is what is meant, and this is the property of a microemulsion. Understood?
Yes, ma'am.
Yes, ma'am.
Okay. Again, this containers may be rendered free from pyrogens by adequate cleaning by
Auto cleaning at 121 degrees Celsius for 1 hour.
correct. 15 minutes नहीं होता, 30 minutes to 1 hour होता है auto cleaning. Heating भी होता है, but heating का temperatures are different. It's 160, 170 degrees and all of that. I will share with you all what is the exact temperatures and time. But 210 and 100 नहीं होता है. This is the most appropriate answer. Moist heat, कौन सा technique is more efficient? Heating, normal heating, or moist heat sterilization?
Moist heat.
Moist heat, because it is going to penetrate more, right?
And here the heating refers to dry heat, no?
Yeah, heating refers to dry heat.
Ma'am,
Okay.
then the temperature is 160 to 170 degrees Celsius.
160, 170, and I think 180 भी होता है, if I'm not wrong, for a lesser time. ठीक है?
Yes, ma'am.
So, autoclaving is the correct answer here. Okay, here we went with this, right? But even this is the correct option. Which of the following is not an intensive property? What is an intensive property and an extensive property? Anybody?
Ma'am, for intensive property, they do not depend on the amount of the substance.
Correct. Who's this?
Ma'am, Akshaya.
Very good. Correct. Intensive property matlab intensive, independent of the amount of substance. Extensive properties are dependent on the amount of substance. Okay? मतलब in other ways, intensive property को तुम add नहीं कर सकते. Okay? Intensive property को add नहीं कर सकते. Extensive properties को तुम add कर सकते हो. All right? A plus B will give you AB for extensive property. But for intensive property, A plus B will give you C. So उस हिसाब से what is the correct answer here? Not an intensive. मतलब which
Volume.
is extensive?
Volume.
Who's this?
Sejal.
Huh?
Ma'am, Sejal.
Okay. Correct. Volume को तुम add कर सकते हो. 100 volume, 100 ml and 200 ml will give you 300 ml. But concentration में वैसा हो सकता है? नहीं. Density, pressure में वैसा हो सकता है? नहीं. Temperature में भी नहीं हो सकता. Hardness, refractive index, वो सारी चीजों को भी तुम add नहीं कर सकते. Things like volume, mass and all you can add up. Okay? So intensive property is independent of the amount of substance. You cannot add them. Extensive properties can be added. They are dependent on the amount. Okay? Anam?
Yes, ma'am. मेरा एक क्वेश्चन था मैम, लास्ट ईयर भी सेम ऐसी क्वेश्चन पूछा था, और उसमें एक ऑप्शन था सरफेस एरिया करके, तो व्हाट शुड बी द आंसर? सरफेस एरिया इन प्लेस ऑफ कंसंट्रेशन, वहाँ एक ऑप्शन था सरफेस एरिया, तो हमें क्या ऑप्शन चूज करना चाहिए?
Surface area.
Yes, ma'am.
Doesn't surface area become additive? You can add them, right?
Yes, ma'am.
Surface area becomes additive. That becomes like a total surface area then. जो भी add करके मिलेगा, that will become a total surface area. So that becomes extensive.
Okay, ma'am.
Okay. Yeah, this one was discussed. So what was the answer here?
B, option B.
Q1D.
Yes. Okay. Which of the following method is used for determination of osmotic pressure? Yes, Komal?
Option B.
Very good. कहाँ पढ़ा है?
आपने जब लेक्चर लिया था तो लेक्चर में बताया था ये.
Colligative properties.
हाँ, colligative properties.
Yes, correct. So Beckmann's method is used for understanding the freezing point depression. Okay. It won't tell you the freezing point of a pure solution. It will tell you the difference of the freezing point between the solution and between the substance. Okay, the difference. So it is also called as a differential thermometer. Cottriell is again used for determination of boiling point, but it's उसका mechanism अलग है. वो उसमें overheating नहीं होगा. And Landberger's में तुम्हें molecular weight का determination होगा in this method. Osmotic pressure determination will be by Berkeley and Hartley's method. Okay, ये method में क्या होगा ना? Now you have your movement of solvent from one compartment through a semi-permeable membrane into another compartment. Okay, so ये जो solution है ना, यहाँ तुम piston से pressure लगाओगे, इतना pressure लगाओगे कि osmosis रुक जाएगा. So वो pressure से you will calculate the osmotic pressure. So here the answer is Berkeley and Hartley's method. Okay.
Ma'am, Landsberg method is used for determination of
molecular weight. Okay. Now this is very easy. I don't want anybody to randomly answer this. Who hasn't answered? Niharika. Niharika. Okay, you're not there, Niharika. Who else? Sonali? Sonali? Sonali is also not there, seems. Anam?
Yes, ma'am.
Anam, what is the answer?
Ma'am, dilatant flow.
Good. System जिसका shear से volume increase होगा वो dilatant है, which will become less viscous would be what, Anam? Shear apply करने पे less viscous होगा, वो क्या होगा?
Ma'am, plastic flow.
Plastic कैसे? Pseudoplastic. If you're applying shear and
sorry.
कम हो रहा है तो that is pseudoplastic.
Pseudoplastic.
Dilatant and pseudoplastic are opposite. Plastic flow will मतलब shear should reach a certain yield point only after which it will start flowing. So that is plastic flow or your Bingham body. Okay?
Yes, ma'am.
Okay. The properties of solution containing surface active agent change sharply over a narrow concentration range and is called. अनुजा ने आंसर किया है? Namira, Sejal. Has Sejal answered? Sejal, unmute your mic. Sejal. Sejal is also not there. Namira. Namira.
Hello, ma'am.
Yes, Namira.
Ma'am, I'm Sejal.
Okay, Sejal.
Sorry, ma'am. Ma'am, I can't see the
What's
question.
wrong with this? I'm so sorry. The answer was constant. When you use surface active agent, it changes at a narrow concentration range. What is the answer for that?
Ma'am, mice.
Yeah, this is the question.
Critical micelle.
CMC, ma'am.
Correct. CMC is the answer. Okay. Surface tension, ये सब ionic and all. I think ये तो very easy to eliminate and very direct answer है ये. Correct?
Yes.
So yeah, I think we are done with all the questions. This was cup and bob, small volume.
No, ma'am, the answer was large volume.
No, so I'm sorry, not added to large volume. Okay. Go through these questions. Do you all have any doubts? I think we should get 5 wrong according to the changes I asked for. 4, 5 or 6 wrong मिलना चाहिए. Any questions? Any doubts? वो LVP and SVP का हो गया sort? Hello.
Yes, ma'am.
Yes, ma'am.
और मानसी को दूसरा कौन सा डाउट? बल्क डेंसिटी वाला हो गया सॉर्ट? हेलो
Ma'am, bulk density में as the particle size decreases, the bulkiness increases. मतलब ये true है ना?
Yes, ma'am.
As particle size decrease.
Yes.
As particle size decrease. No. Even this is false. मतलब छोटे particles का, don't you think the bulkiness will be more? 1 minute. Bulkiness will increase because हाँ. Bulk density का reciprocal है. हाँ, what? Hello.